Hello students, welcome to my channel Math Excellence. Today we are discussing another test which is ANOVA test. In my last videos I have discussed with you about the Z test, T test, F test, chi-square test, what are the condition of all these tests, how you can by looking the question you can say yeah in this question or in this type of data in this type of problem we need to apply this test. So in my last videos I have discussed those tests with you. So today we are discussing about the ANOVA. ANOVA is a two type of test. First one is one way and second is two way. And now I'm discussing in this video, I will discuss with you ANOVA one way. So first of all, before starting any problem, I'll discuss what is the basic condition of ANOVA one way. ANOVA test is applicable, guys, if we have two, three or more populations. Suppose if you have only two populations. So already I have discussed with you on one single population or on two population, we can apply T test and we can also apply Z test, correct? For the Z test, the sample size should be n greater than equals to 30 T test. It should be less than 30. But suppose if we have populations more than two, number of populations you have a three companies like in this way. So this test is applicable, and here you're also checking the equality of variance of all the population. Again, I'm repeating, when you have more than two population as well as you are checking the equality of the variances, at that time you always apply the ANOVA test, whether it's a one way, two way, you always go for ANOVA test. Second point, how to check that now it's clear that when we apply the ANOVA, the second question ANOVA is one way as well as two way ANOVA here. How you can check that I should go for only one way? So the important point is that students, in ANOVA one way, we have always only a single factor. Keep remember, if we have only a single factor, we always go for one way. Now, for example, we have number of populations, like take the number of companies. I'll take, okay, the number of companies we have. In all the companies, we are just focusing only on one thing, that is brand, okay, or brand value, whatever you want to say. So all these three companies, they are focusing only on one thing. What is this? Brand, only brand. It means they are talking about single thing, one factor. Definitely we have to go for one way. But let's suppose these three companies are focusing on brand, sales, profit. They are also focusing on margin value, lot of things, many factors at the time they are focusing. So then you have to go for two-way ANOVA. So when we apply the ANOVA, when we have three or more populations and we are going to test the equality of variances over there, we always go ANOVA. That now second question, one way or two way. So one way means when you're focusing only on single brand, only one brand, or sorry, one factor. I'm using the lot of brand. I'm sorry. When you are just focusing on single factor, one factor, it means we have to go for the ANOVA, but one way. If more than one factor, so definitely we have to go for the ANOVA two way. So I think these two conditions are clear to everyone. Now, process as we know, take the null hypothesis, alternative, find the critical values, and compute the test by the ANOVA test, and at the last take the decision. Okay, so let's start with the example, students, that how we can solve ANOVA one way, how we can apply. In this question, read the question that three samples. We are talking about three samples. So if we have three samples, obviously how many populations you have? Three population. Below have obtained from normal populations with equal variances. We are saying that all these three samples variances are same. Test the hypothesis at 5% level that the population means are equal. We have to see that population means are equal for all these three populations. Now, and one more thing they have given to us for 5% level of significance for class, this is new one. This is first degree of freedom. Please keep remember. This is second degree of freedom. Okay, this is already given to us. And for the first and second degree of freedom, we have the values of 3.88. And in my question later on, I will tell you what is these two degree of freedom we usually denote. So I think question is clear to all. So let's start to solve the question step by step. We will solve ANOVA one day. So any question, if you have any random question, you can choose which is based on ANOVA one way. So process for all the question is same. So let's start. First of all, guys, we will take the null hypothesis. What is the null hypothesis? There is no difference. How many populations we have? Three. So obviously, for all the three population, mean is same. Okay. Now let's proceed further. So how to start this question? First of all, I have three popular samples. Okay. So first x1 we have the values 8. Please solve this question with me. 7, 14, 11, x2 7, 5, 10, 9, 9, and x3 value we have 12. Let me write 9, 13, 12, 14. That these three samples we have. So first of all, class first step is this, that firstly we will calculate the individual mean of all samples. How many samples we have? Three. Individual mean you will calculate x1. So you know that there is x1 bar upon n. So what is the total of this one? Calculate, and the total is 50. So this is 50. How many values we have? 5. So this is 10. So x1 bar is 10. Okay, we got first individual mean. Now students go for second individual mean. Step by step, I'm solving this question. So I suggest you solve this question with me. Okay. Now what is x2 bar? Sum of this one is we need, if we see 40. So it's 40 by 5. So my x2 bar is, that is 8. 5 8 40. That now calculate x3 bar. This is my first step to calculate the. This is first step to see individual means. X3 bar divide the total number of observation. And x3 total is 60. So it's 60 by 5, which is 12. So we got x1 bar, x2 bar, and x3 bar. We got individual means. This is the first step. Okay. Now, guys, second step is we have to calculate the grand mean. Okay, grand means the overall mean. Overall mean, you know that for individual samples, we have the mean. Just find the average of that, those individual means. You will get the total mean or grand mean. So, x1 bar we have calculated, that is 10. X2 bar is 8. X3 bar is 12. Divide by 3. So what we got now after calculation, so my grand mean is 10. So x1 individual mean we have calculated, that was the first step. Second step is find the total mean. Okay. Now third step is this, guys. We will calculate variance between samples, between these sample values. We will calculate the variance. How to calculate between sample? It's I is equals to 1 to 8. Then I is equals to 1 to 8 xi minus x bar whole square. Okay. And xi bar. Now xi bar, how many I values we have? We have 3 because 3 sample. So if I'm writing xi bar, so xi bar is what basically, first of all, what is this? This is sum of square. Many times in my last video also I have used this word. So I think this is now clear to all. This is sum of square of deviations. Okay, second thing I'm saying, guys, it's xi bar. So xi bar means I value is 1, 2, 3 because 3 samples. So this is sample mean, or you can write individual mean, and this is grand mean. Done? Okay. So first of all, we calculate x1 minus x1 bar minus x bar whole square. Okay. Then the third step, x2 bar minus x bar whole square. Then x3 bar minus x bar whole square. Then how many observations we have? 5. What is x1 bar? X1 bar was, we have already calculated x1 bar, x2 bar and x3 bar. X1 bar was 10. So first value was 8. Sorry, x bar is 10. X1 bar, I'm writing here, x1 bar is 10. X2 bar is 8. So it's easy for us to calculate. So 10 minus 10, first observation 0, second obviously all the observations will be 0. And this one, because we have 5 number of observation, for all the 5 observation, answer will be this one. 4, 4, 4, 4 and 4. So total is 0. This one total is 20 and this one total is 20. So guys, you will calculate SSC, which is x1 minus x bar whole square plus x2 minus this one. I'm calculating this one now. X2 minus x bar whole square, x3 minus x bar whole square, which is 0 plus 20 plus 20. This is 40. But what is SSC now? Already I have discussed here. This is, I'm writing here, sum of square between samples. Okay. So what is SSC? SSC is sum of square of samples. So this is my third step, because you can see I have mentioned I am finding sum. So I have calculated here x1 bar, sorry, minus x bar whole square, x2 bar minus x bar whole square, x3 bar minus x bar whole square, which is 40. And this is my third step. First step was individual mean, second step was grand mean, third step variance between the samples. Okay. Now we are going for the next step, students. Next step is variance within samples. Third step, we have calculated variance between samples. Now variance within samples. If this its formula is same thing we are applying, but the formula is xi minus x I bar whole square. This is xi minus x bar. And in the third step, we have solved with the help of grand mean. Now we are solving with individual mean. Okay, so let's start to solve. First, I'll write x here because I require x1 right now. Then x1, because I value is 1 to 3. X1 minus x1 bar whole square. Done. Then x2. Then we'll calculate x2 minus x2 bar whole square. Okay, let me erase this one. Okay, then I'll calculate x3 and then x3 minus x3 bar whole square. Okay, x1 bar, what was the values? 8, 10, 7, 14, 11. X2 values is 7, 5, 10, 9, 9. Solve this question with me, guys, because any question which is related to ANOVA one day, we have to solve by the same process. 12, 14. Then, now what is x1? 8. What is I'm writing here? X1. Okay, that is, I think we can easily understand. What is the first value? 8. What is x1 bar? Already we have calculated 10. So 8 minus 10 minus 2. Minus 2 square. This is 4. Okay, then 10 minus 10, 0. This is 3, so 9, 16, and this is 1. Total is 30. This will be solved, so I'm getting 1, 9, 4. Do the calculation with me, please. This is 0. This one is 9, 1, 0, 4. Total is 14. Now, in the third step, we have calculated SSC. Now we'll calculate SSE. So what is SSC? SSC was sum of square between samples. So what is SSE? This one is sum of square within samples. Okay, that was between samples and this is within samples. Between samples we solved with the help of grand mean, and this one we have solved with individual mean. Okay, so just calculate, and I'm writing the formula first. X1 minus x1 1 bar whole square plus x2 minus x2 bar whole square. I'm just applying this formula here. I'm just putting I is equals to 1, 2, 3 by because we have 3 samples. Okay, and then x3 minus x3 bar whole square. Now what is this? 30 plus 16 plus 14. Total is 16. 60, sorry, we got. Now I'm going for last step. This is fifth. We will make ANOVA table. Okay, ANOVA table. This is very important. Keep remember how to draw. First is source of variation. Source of variation. Second is sum of squares. Yes, sum of squares. Next, degree of freedom. Okay, 2 degree of freedom, guys, we have in this question. Then mean square. Okay, this is our ANOVA table. Okay, so here I'll write SSC. You know, SSC means between sample. SSE means within sample. Sum of square already I have calculated. What is SSC value? 40. What is SSE value? 60. We have already calculated this one in third and fourth step. Here I'll write total. Okay, then 40 plus 60, 100. Okay, what is first degree of freedom? 2, which is already given me in the question. 12. Total is 14. Mean square means SSC means first degree of freedom. 40 by 2, which is 20. And this is SSE by second degree of freedom. This is first degree of freedom. 60 by 12, which is 5. Then so we got first value between. This is between samples and this is within samples. So we got 20 and 5. So put the value in F statistics. Okay. So F statistics formula is variance between samples. Okay. Divided by variance within samples. Okay, so between samples we got 20 and within 5. So F value is, oh, this is my calculated value. Table value is already given me in the question. What was the tabulated value which is mentioned in the example? Tabulated value was 3.88. So my calculated is greater than tabulated. So definitely I have to reject the null hypothesis. So question is completed. So keep remember any ANOVA test you have. So these are the following steps you have to follow. Any ANOVA one way you can solve right this way. This question you can take it as your example. Again, 3 samples we have. Degree of freedom is given and you can solve. So just keep remember what are the steps we have. Again, I'm just telling you what are the steps we have. First, take null hypothesis. Then second, we will calculate individual. Please note it down. These steps are very important. Calculate individual means. Third, calculate grad of total mean. Fourth step, solve SSC means sum of square between samples. And its formula is summation xi bar minus xi whole square. Okay, so I will make a correction. It's solved with the help of grand mean. 1 second. This one formula is summation xi bar minus x bar whole square. Fifth step is SSE, which is within sample. And what is the formula? Summation xi minus xi bar whole square. Then next, make ANOVA table. 7th, find F value and question completed. So these steps we need to follow for any ANOVA value. Thank you, students.